Okay, so for today's lesson, we're going to talk about sensors. We're going to continue our discussion of analog versus digital sensors, and specifically analog sensors, because last time we did discuss digital sensors. But first, to review. Um, from looking at your homework, I had the feeling that there were maybe one or two of you who didn't quite grasp what a sensor was. So let me first talk about that. So a sensor senses the environment around it. So it might take an input of a button press, as a digital sensor might, or it might take an input of temperature or pH levels, or um, humidity or lack of humidity, or light or distance from an object. It takes these values and it relays it to a computer or a circuit or something, maybe even something mechanical. And then there is an action based on that data. So, for example, a thermostat takes in what temperature is actually in the room, and it decides whether it needs to turn on the heat or the cold in order to get to the desired temperature. So it uses that sensor value accordingly. Um, I think a good representation of sensors, and specifically the difference between an analog and digital sensor, is this PS4 controller. So first, to review, a digital sensor will take values from 0, 1, 2, 3. It's not just that it takes whole numbers; it's that it takes everything in steps. So you could have a digital sensor that only reads 0, 0.5, 1, 1.5. That's rare, but it's possible. That's still a digital sensor because it senses as a step function. Whereas an analog sensor, its value curve looks like, well, a curve instead of a step function. You get a range of values. You get decimals. You get hundredths, thousandths in your sensor values. Some examples we talked about of digital sensors were limit switches and bumper switches. And we talked about how a potentiometer, which gives angle, could be used as a digital or an analog sensor. And that could be made as a digital or analog sensor. It really depends on the application. Now, we talked about limit switches, and I think a limit switch is a great example because this is actually something you might not realize, but that literally in the form that we've had in our class, um, exists all over the place in the real world. The most common example is in elevators. There's a very similar limit switch used to detect when an elevator reaches a certain floor. So there's one of these limit switches with these flags, and the flags are bent at certain angles to detect when an elevator reaches a certain floor. Some other examples that I saw in your homework was a button on a controller someone put, and then someone else put buttons on elevators. I just saw a lot of people talking about buttons. Some other examples are like if a sensor just detects if there is light or isn't light in a room. That could be a digital sensor. It could also be an analog sensor that senses how much light there is in a room and then does something once it reaches a certain level on the curve. So let's say this is our light sensor graph, and these are the values. There might be just like a line, and if it's below, if the light is below this line, if the value of the light in the room is below this line, turn on the light, something like that. Okay, so we talked about digital sensors. Let's talk about some analog sensors. We already mentioned a potentiometer, which gives us angle. The next one I'll talk about is called an ultrasonic rangefinder. Or also known as a sonar sensor. So an ultrasonic rangefinder, or sonar. Sonar might make you think of a bat. Well, it functions kind of like how a bat sees. For those of you who already know this, you might know a bat sees by bouncing um, sonar waves, sound waves, off of surfaces, and then how long it takes for them to bounce back tells them how far away surfaces are. So let's say this is my sensor. What it'll do is it'll emit a wave, and when it hits an object, that wave will bounce back, and it'll tell you how far away that um, object is. This is very useful. This is commonly used in cars. Some cars use camera sensors, some use sonar sensors to tell you how far away, when you're backing up and your car starts beeping, that there's something close by. Well, this is likely the sensor that would be used. The next kind of sensor we're going to talk about, another analog sensor, is a line tracker. This, zoom in a bit, can be digital. So it could be, there's a line there or there isn't, but generally the way a line tracker works is it'll sense the color of what's underneath it, and based on, you'll get a big change in value from black to white. So let's say you have a car driving on a road, you might use a line sensor to sense where those lines are. If you're floating out of your lane, it might detect that because there's that sudden change from black to white under the sensor. Now, that could be a digital one where it senses black or white, but generally it's an analog sensor where it is taking a wide range of values, and black might be 11,000 and white would be 240, something like that, and based on that it has a digital response. The next sensor we're going to talk about is a light sensor, and this also can be digital, but in general it isn't. A light sensor generally will give you a value depending on how much light is put on it. I think a very common application of a light sensor is on your phone. On my phone, I don't know about you guys, but I have the brightness set to be automatic. So if I'm in a dark room, it doesn't become crazy light, and if I'm in a light room or I'm outside, it gets very bright so that I can still see my screen. So it uses a light sensor to detect how much light there is outside in the environment I'm sitting in, and it has a responsive setting screen brightness to it. So that's another example, is a light sensor. Another is an optical encoder, or an encoder. Let me actually go back and define some of these. So I'll backtrack. A line tracker gives values based off color under it. Light sensor gives values based on how much light there is, specifically how much light is directly on the sensor. And then an encoder. So an encoder is kind of similar to a potentiometer. If you look closely, you'll see that there's this hole in the middle. An axle or a shaft goes in there, and this will detect how many times something has rotated. So returns number of rotations. This also can be digital or analog. Sometimes encoders will only detect by rotation, so 0 rotations, 1 rotation, and can't detect half rotations. Sometimes an encoder will have 360 possible values it gets. So it goes 0, 1, 2, 3, and all the way to 360 to indicate that it's gone 360 degrees. And then after it goes 360 degrees, the computer knows that that's been one rotation, and it adds to it. So, but in general, it's an analog sensor where it's just sensing how far an axle has rotated. On our Clawbots, this is something where you would put this on your drivetrain, and if you wanted to automate how far you wanted your robot to move, you would put an encoder on the drivetrain, and the encoder would return values based on how many times the wheels have rotated, and then you would do math to figure out how far your robot has moved. Okay, and this is just another type of an encoder. Some other interesting ones, a gyroscope. So a gyroscope or gyro. Not a gyro that you get at the hall cart. A gyro will tell you angular rotation. So let's say you want to turn a specific angle. A gyroscope will tell you that. There are gyroscopes in your phone. That's how my phone knows when I flip it over to turn the screen on. It uses a gyro. It detects angle. It detects angle in every direction, the X, Y, and the Z. There are lots of applications that utilize this. GPS utilizes this. Trying to think what else. But there are lots of applications that utilize the gyroscopes in your phone. A lot of devices today have gyroscopes. So returns angle of rotation. So this is particularly useful for robots because let's say, again, going back to the clawbot, if I wanted to automate movement and I wanted to have the robot go forward a certain distance, I would use an encoder. But if I wanted to have it turn a set angle, that's where a gyroscope would come into play. Okay, so that's going to be it for the sensors we talk about today. The most important thing that I want you to take away from this, these are the sensors. They're really interesting. They're really cool. They show up all over the place, and you should look for them in your real world. But you should really understand the big difference between an analog and digital sensor is, in general, a digital sensor is just a button. Press a button, take a value. Press a button, take a value. Whereas an analog sensor will give you a wide range of values depending on what is actually happening. So temperature. That would be an analog sensor because you're getting, even though you might get, you might see on your thermostat just whole number degrees, it's sensing degrees in a wide range. It's not just sensing 71, 70, 69. It's sensing 69.3. It's sensing a wide range of values. Okay, so that's it for today. For homework, I want you to think about some analog sensors that I haven't mentioned in today's lesson and list them out. I'll give you an assignment just like I did last time. And I'll see you guys on Monday.